Let's begin. Today's September 13th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 5, 9, 12, 18, 19, and 20. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our first digit, the triangle digit, and will let us know whether it's an even digit or an odd digit. Criteria card B looks at our 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C looks at our first and last digits, triangle and circle, and compares them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D looks at our 3 digits, triangle, square, and circle, adds them up, and the Turing machine will let us know whether that sum is an even quantity or an odd quantity. Criteria card E looks at our first 2 digits, triangle and square, adds them up, and compares it to the number 6. So should the sum of the digits be less than 6? Should they be equal to 6? Or should they be greater than 6? And finally, criteria card F again looks at our 3-digit solution, but this time tells us a little bit about its structure, so to speak. Specifically, it can let us know whether there are no repetitions in the code, as in the example 125, or it could tell us that there is a double number, a repeating digit, as in the example 112, or it could even tell us it's a triple number, or it's a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards. And we're going to start off with an initial proposal of 314. So the first thing I want to test is I want to know a little bit about that triangle digit. So let's go ahead and test criteria card A. Okay, so the Turing machine does not approve of my choice. I did pick an odd 3. So it's basically telling me that triangle should be an even digit. So let's go ahead and type that up in the notes for section A. And that again is that triangle is an even digit. And of course, since it is even, I can cross out all of the odds for triangle. So crossing out 1, 3, and 5. So the next thing I think I'd like to test is criteria card F. Okay, so this time it does approve of my proposal. Notice that in my proposal of 314, all the digits are unique, meaning there are no repetitions. And the Turing machine agrees with that. So let's go ahead and type that up in the notes for section F. And that's that the solution has no repetitions. Okay, so basically, yeah, the 3-digit code should should have no repeating digits. Okay, and let's go ahead and test criteria card D. Okay, so again, the Turing machine does not approve of my proposal for criteria card D. Notice that we are adding all of the 3 digits, so let's go ahead and add up 3 and 1 is 4, and 4 plus 4 is 8. That is an even quantity, but because the Turing machine disapproves of it, it's letting me know that actually the sum of the 3 digits should be odd. So let's go ahead and type that up in our notes for section D. And that again is that triangle plus square plus circle should be odd. Okay, so let's see. We do know that triangle is even. If I want the overall sum to be an odd quantity, I believe that means that among square and circle, one is going to be an even and the other an odd. So the reason that's true is because when you add up two evens, that sum so far is an even quantity. But if you want the overall sum to be odd, then you introduce an odd. And so that way the overall sum is actually odd. So let's go ahead and add a note here and say we have two evens and one odd. Okay, well that does it for this round. We did complete our 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card B, the number of 3's in our solution. Well, at this point, since we only have one odd, we know it's either there or it's not. So it's either one 3-digit in the solution or none at all. But there still has to be an odd value, so a 1 or a 5 if it's not there. Then criteria card C, we did not test either, and that compares triangle and circle, and then of course the first 2 digits in criteria card F, adding them up and comparing it to 6. So normally, yes, when we have criteria card E, where we're adding up the first 2 digits, and we have 2 evens, sometimes the sum of the first 2 digits is 6, meaning that it's a 2 and a 4 in some order. That's a possibility. Otherwise, it is going to be an even and an odd, triangle being even, and I guess potentially square could be odd. So those are the 2 basic scenarios. Now, how does the sum of the first 2 digits, of course, that could be 6, then how would criteria card C come into play? So if we're dealing with 2 evens in triangle and square, I guess we could have a 3. We know the circle would be the odd one, and if there's a 3 there, then I guess we could know which of the 2 evens go in triangle. So it could be either, yeah, there's a 3 and it's bigger than triangle, meaning it's going to be a 2, or it could be the other way around, where you do have a 3, but circle is smaller than triangle, meaning that triangle is a 4. So that's a possibility. And that's kind of how I see it. I mean, again, it could be that square is odd. Let's go ahead and do 4, 2, 3. So we are going to go with a sum of 6, meaning we do have 2 evens, and there is a 3, and then circle is smaller than triangle. So let's go with 4, 2, 3. Okay, so the whole purpose of this proposal is really to test criteria card E. So let's go ahead and do that. Okay, so the sum is not 6. Okay, so that means that square is actually the odd value. So let's go ahead and type up something for section E, and that is that the sum of triangle and square is either less than 6 or greater than 6. So that sum is either less than or greater than 6. So let's see. So, so of course, then, as we stated, square must be the odd. So let's go ahead and cross it out. Cross out the evens in square. And similarly, we can cross out the odds in circle. So we're looking at an even, odd, even solution. Okay, so let's see. Will we be able to deduce? So we don't know if triangle and circle could be even. I guess potentially they could. There's nothing really indicating that it can't be equal. I was under the impression that perhaps maybe square could be the even and the sum would be 6. So yeah, at this point we really can't just ignore that possibility. So now that it is interesting, now square is has on, or there is only 1 3 among all the solutions or possibilities. So yeah, I don't know. Could it be 1 3 or 5? I guess it also depends on what the sum of the first 2 values are. I think they're equally balanced. I think you can have 2 1, 2 3. Those are all going to be less than 6. And then you have 2 5, or let's see, or actually, yeah, 2 1, 4 1, 2 3. Those are 3 possibilities for less than 6. And then you have 2 5, 4 5, and 4 3 as 3 other possibilities for greater. So there is, I guess, a sort of 50-50. I guess if there is no 3, could we somehow tell? It'll be interesting. Well, let's go ahead and test criteria card C, and let's see what we get. Okay, so we got lucky, even though the premise of the whole proposal is now, out the door. We were still fortunate to discover that 4 is greater than 3, so triangle is greater than circle. So let's go ahead and type that up in section C. And again, that is that triangle is greater than circle. And since we are dealing with 2 evens, okay, so now we know for sure that triangle has to be 4 and circle has to be 2. So let's go ahead and cross out the 2 for triangle and the 4 for circle. Okay, and at this point, yeah, I guess there's still some possibility. Yeah, and we may, well, let's see, at this point, what are we looking at? We're looking at 4 1 as the smaller than 6, and 4 3 and 4 5 for the sum greater than 6. And unfortunately, well, let's see. Yeah, I think we're going to have to do a third round, just a quick one. But I guess the question is, more than likely it's going to be greater than, and we're either going to include the 3 or exclude the 3, and that would give us 5. But let's go ahead and test criteria card B all the same. Okay, so there is no 3. So yeah, so either the sum is going to be less than or greater than. And so yeah, it's just a toss-up. Let's go ahead and do 4 1 2. So 4 1 2, and we're going to test basically criteria card E again. Okay, so it is not less than, so indeed it's got to be greater than, and so that means it's going to be a 5. So let's go ahead and cross out the 1. And so, yeah, it looks like the solution should be 452. And I did forget to type in the notes for B from the previous round that the solution has no 3-digit. Okay, and of course then I can also update my notes for section E that the sum has to be greater than 6. Okay, so really quick, is the first digit even? It sure is. The solution has no 3-digit, that's right. The first digit is bigger than the last, it is. The sum is odd. Yeah, 4 and 5 is 9, 9 and 2 is 11. That is odd. We do have 2 evens and an odd. That was a deduction. The sum of the first 2 is greater than 6. Yes, 4 and 5 is 9. And no repetitions. Yep. So it looks like we got it. So, but let's actually confirm, and let's see if 452 is correct. Okay, fantastic. Now, how do we do versus a Turing machine? So we did do 3 rounds. So we tested 7 criteria among 6. That's not too bad, but let's see how we did. So it looks like in the first round we did ADF with the last being correct, and then we did the remaining 3 criteria cards, BCE, and the middle one was correct. And then we did E again, and that was incorrect. So let's go ahead and do that again. ADF. So A was wrong, D was wrong, F was correct. And the second round, B was wrong, C was correct, and E was incorrect. And then I believe, was it D or E? It was E that we tested twice. And that was also incorrect. Okay, so we beat the Turing machine by 1 question. We both went to 3 rounds, but we did in 1 less question. I'm not sure where exactly our gain was. Maybe the deduction that there were 2 evens and an odd. I'm not sure, but it still worked out very well. Well, what do you think? How did you solve it? Add your thoughts if you saw anything in the video where we could have made some improvements. If you liked the video, please do give it a thumbs up, and of course hit subscribe to not miss out on any future videos. Well, until next time, have a great one.